Hello and welcome to this lecture on assessing weight status. To start the lecture, it's important to put in context that, well, of course you're probably aware that many people in the United States are overweight or obese. It's interesting to learn just how quickly we've gotten to this point. Now, we haven't kept obesity data in the United States forever, but from the last couple of decades from which we have, we see that. Let's look back 1998. In 1998, most of the states had obesity prevalence rates of less than 20%. And you'll learn in this lecture what quantifies as being obese. But basically, if your entire state's population, those that you see posted there that are blue, dark blue is 15 to 19% of the state was obese, and then light blue is 10 to 14% of the state. So, the yellow ones were 20 to 24%. And most of the states you can see in 89 were not yellow. Now, fast forward to 2011, by then almost the majority of states had obesity prevalence rates not even just above 20, but above 25%. And there were 12 states that reported obesity prevalence rates of at least 30%. Now, you'll learn momentarily that obesity is different than overweight. Obesity is more severe than overweight. And roughly in the United States, it's safe to say that about 1/3 of the country is overweight and 1/3 of the country is obese. So that's where you hear that statistic that 2/3 of the country is overweight or obese. So yes, we have very high rates of overweight and obesity, but it's really just been in the last 20 or 30 years that we've seen the rates skyrocket so precipitously. We've gotten really fat really fast. As I mentioned, about 1/3 of the people in the US can be categorized as being overweight, and about 1/3 can be categorized as being obese. Overweight refers to having a BMI, a body mass index, of 25 to 29.9. And I'll show you how to calculate BMI in a second. Obesity is having a BMI of 30 to 39.9. Healthy weighted people are those whose BMI falls between 18.5 to 24.9. Underweight is a BMI of less than 18.5, and extreme obesity is BMI of greater than or equal to 40. Why are we so concerned? Who cares if people are overweight? Maybe they just don't like the way it looks. Is that the only issue? Okay, no. You can certainly be overweight or even obese and be metabolically healthy. And I want you to keep that in mind as you're learning about overweight and obesity during this module. But there's a concept known as metabolic fitness. You can kind of think of it along the lines of it's what's on the inside that counts. Yeah, you might be overweight or obese, but if you've got good blood pressure, good blood sugar, and your cholesterol values aren't that high, plus if you're physically active, then being overweight or obese actually isn't that bad of a thing. The reality, though, is that most people who are overweight and or obese, because you can't be both, so one or the other, they're not healthy on the inside. And that's where we're concerned. Because we know at the high end of the obesity and overweight spectrum that there's increased health risks. People with higher BMIs tend to have higher blood pressure, more heart disease, higher cholesterol levels, more propensity for diabetes, gallbladder disease, arthritis, sleep disorders, breathing problems, irregularities with menstruation, which makes it difficult to get pregnant when you want to, higher rates of certain types of cancer, infectious disease, poor wound healing, surgical complication. The list goes on and on and on. Again, it is possible to be healthy weighted or overweight and healthy on the inside, but most people are not. Next up, we're going to learn about body mass measurements. We're going to learn about the BMI. Okay, BMI stands for body mass index, and that's what we use to categorize people as being underweight, healthy weight, overweight, or obese. The way you calculate BMI is to take the weight in kilograms divided by your height in meters squared. Now, since you're probably not inclined to knowing your weight in kgs and your height in meters, an easier way to do it is to get your weight in pounds divided by your height in inches and multiply that times 703. So let's do a sample one together. Okay, get your calculator out. And let's say we're working with a person who's 5'8" and weighs 160 pounds. Okay, 5'8" is the height and 160 pounds is the weight. What's that person's BMI? Here's how we calculate it. First, you take their weight in pounds, 160 pounds, divided by their height in inches squared. So you can do 160, hit divided by 68, because that's 5'8", and then divided by 68 again, times 703, equals. And I got 24.3. I'll do it one more time if you missed that. It's 160 pounds divided by 68 inches divided by 68 again times 703 equals 24.3. So keep that number in mind. A person who is 5'8" and weighs 160 pounds has a BMI of 24.3. Well, what does that mean? As you can see from the chart here, having a BMI of 24.3 would put that individual in the healthy weight category. Okay, if his BMI was 25.3, he would technically be classified as being overweight. And if it was 35.3, he would be in the obese category. Okay, so we use height and weight to determine BMI, which in turn tells us which weight category we're in. Now, there's all sorts of limitations to the BMI. Think about it. You just use someone's height and weight and then put them in a category. But what about their age? What about their race? What about their gender? What about their activity level, or what percent muscle they are versus lean? All of these things, of course, play a role in health. So just looking at BMI doesn't give us the full spectrum, but it does kind of allow us to help point out trends. So we acknowledge there are certainly shortcomings with the BMI. To be honest, it's used a lot in research because it's cheap to obtain, right? Just get someone's height and their weight, and you can put them in a category. We're interested in knowing what BMI is because we know that the relationship between BMI and mortality is described as what can be said to be a J-shaped curve. So take a look at this slide where you see the body mass index increasing on the x-axis and risk of mortality increasing along the y-axis. You can see that people who are at very low BMIs, less than 18.5 is classified as underweight, or high BMIs, above 30, which is obesity, you start to see increased risk of mortality. Now, as I said earlier, there's always outliers. You can have underweight healthy people and obese healthy people. But more often than not, the risk of early death is going to go up if you're very, very underweight or very, very overweight. Something else about weight that you might be interested in calculating is what's called the ideal body weight range. Now, that very name in itself should raise red flags because there's no one ideal weight for all people. However, especially if you're moving to working in a field of healthcare or clinical nutrition, you sometimes have to document how people compare to their ideal weight. Okay, there's lots of factors that go into determining ideal weight, but if we're just going to use gender and height, there's enough to calculate using what's called the Hamwe equation. And we'll start with females on the right. The Hamwe equation states that in order to calculate someone's ideal body weight, for a 5-foot tall woman, she should weigh 100 pounds. Okay, and then every inch over that, we give her an additional 5 pounds. So let's say this woman was 5'8", we would give her 100 pounds for being 5 foot, then 5 pounds per inch over 5 foot. So she's 5'8", 8 times 5 is 40, so 100 plus 40 is 140. For all ideal body weight calculations, we do plus or minus 10%. So she would be 140 pounds plus or minus 10%, which is 14. So 140 minus 14 is 126, and 140 plus 14 is 154. So somewhere, if she weighs between 126 and 154, she would be within what we call her ideal body weight range. Now for men, it's a little different. Instead of 100 plus 5 pounds per inch, men get 106 plus 6 pounds per inch. It's not fair. They get more weight per pound. But basically, a 5'8" male, he would have a higher ideal body weight than the female. Okay, we would say he's 106 plus 6 times 8, which is 48. So his ideal body weight would be 154. And then to get the range, we always do plus or minus 10%. So 10% of 154 is 15. So his body weight range would be 139 to 169. If that guy weighed somewhere between 139 and 169, he would probably be pretty healthy. Now, it's at this point in the class where all the guys who are 5'8" say, if I only weighed 139 pounds, I would look so scrawny and skinny. And that's probably true. This is just a ballpark range. Okay? If your 5'8" guy weighs 269 pounds, he's 100 pounds overweight. That's where we get those statements from. So this is the Hamwe equation. It's used to determine what's called ideal body weight. If you're asked for an ideal body weight range, it's just plus or minus 10% of that ideal body weight. Okay, it's a starting point. It's not exactly how much you should weigh, but it's a good ballpark. How about your body fat and where it's located? Does that matter? we've got different types of body fat. You have subcutaneous fat and visceral fat. Subcutaneous fat is the fat that deposits in the fat tissue under your skin, for example, in your hips and your legs. We think of subcutaneous as fat as accumulating a lot of times in females who are pear-shaped. You got a lot of padding around your butt and your hips. And a lot of times that's hormonal in nature. It tends to happen in premenopausal women because your body's building padding for the time when you get pregnant and need to go through childbirth and labor. You need that extra fat. Okay, that's pear-shaped. The more dangerous type of fat, though, that we're concerned about is called visceral fat. This is the fat tissue that accumulates around your abdominal organs and causes the apple-shaped appearance. Again, the apple-shaped appearance is more dangerous than the pear-shaped one. You might not like the fat around your butt and your hips, ladies, but it's not dangerous. If you've got a big old beer belly, though, and a bunch of fat surrounding your abdominal organs, that's dangerous fat. That visceral fat is more metabolically active, it leaches into your bloodstream, and is associated with higher disease risk. There's some different types and locations of fat that are of interest to researchers. And for the most part, another unfairness of life is that males are always going to have a lower percentage body fat than an equivalent sized shaped female. And that's because females hormonally deposit more subcutaneous fat in preparation, as mentioned, for childbirth. Your typical active male may be as little as 15% fat, where a female, even though she's really active, might be upwards of 27% fat. And again, that's okay because hormonally, females are going to be genetically predetermined to be a higher percent body fat. It's very difficult for a female to get down to something as low as 15% body fat. And to be honest, for the sake of an introductory nutrition course like this one, it doesn't really matter what percent body fat you are. If you're at a healthy weight and you're exercising on a regular basis, the notion is you should be converting some of your fat to muscle, and don't really sweat the details as far as what percent is body fat. That's something that's kind of reserved more for really intense exercise, for highly endurance or high strength training athletes. The average Joe, work on getting your BMI in the healthy body weight range. If you do that with exercise, you'll build muscle, and that's a good thing. There's a bunch of other ways you can measure body composition. Your book talks about a couple of them, and I'll just show them to you briefly here. The one you see in the middle there is called the BOD POD. Most colleges and universities have one, usually in the athletic department. It measures how much air you breathe out, okay? And then through a series of printouts, it can calculate how many calories you need. What you see on the top left is based on a theory called BIA, bioelectrical impedance analysis. Now, the type of BIA that she's doing, where she holds that handheld, I think it's like a body fat calculator, is really notoriously inaccurate. Okay, BIA can be really good if it's done like in a doctor's office or a research setting. You lay down, they put nodes all over your body, and they conduct a low-level electrical current through your body. And it's based on the principle that fat impedes the current. So your body, based on the readout, they can tell how far the current went, what percent of your body is fat and what percent is lean tissue. If you just do the handheld monitor like that there and you're squeezing it, it's really only extrapolating the upper part of your body. I don't know about you guys, but I have a different fat distribution in the bottom than the top of my body. So those are kind of worthless, and they tend not to be calibrated. They're pretty cheap. A lot of times they're used, in my opinion, by gyms and stuff to make you feel bad about your body fat percentage, so you sign up for another month at the gym. On the bottom left, what you see going on there is what are called the trifold skin calipers. And if you take kinesiology classes, you guys are probably familiar with all of these more so than I would be. If the person using the calipers is very highly trained, and if the calipers are well calibrated, then this can be an accurate way of getting percent body fat. You do a variety of different readings from different parts around the body, plug it into an equation, and voila, you know roughly percent body fat. The problem is most people who administer this, again, are people at the gym who are not highly trained with calipers that are cheap or not well calibrated, and so they can give wildly different readings. On the top right, you see underwater weighing. Instead of using air displacement, there's water displacement that helps determine energy needs, percent body fat, etc. That's used kind of in research settings, pretty expensive. The bottom right, though, is what's called a DEXA bone scan. That stands for dual energy X-ray absorptiometry. And DEXA is actually the gold standard for determining bone mineral density. That's what we use to help diagnose osteoporosis. It also tells you a readout of what your percent body fat is. So DEXA can help determine percent bone mineral density as well as body fat. So those are just some different ways to measure and assess body composition.